Hello, welcome to this lecture where we learn the self-learning topic, antenna polarization. I will just briefly give you what is an overview of polarization and what are the types of polarization. For more details, you can refer Antennas for All Application textbook by John D. Cross, or you can refer any resource on internet for learning this topic in more detail. So basically there is no polarization of antenna. It's not antenna polarization. It is polarization of the waves or field radiated by the antenna. So the polarization of radiated wave is defined as polarization of antenna, and of course the waves are radiated by an antenna when it is excited. So polarization of incident wave from the given direction results in maximum available power at the antenna terminals. So the polarization is important because it tells us the direction in which the maximum radiation is happening. In practice, polarization of radiated energy varies with direction from center of the antenna, and that's the reason why polarization can be categorized as linear, circular and elliptical polarization. So in the linear polarization, the vector, the electric vector radiated by the antenna in the free space varies as a function of time, and it is always directed along a line, and the field is then the field is said to be linearly polarized. Whereas if the electric field is tracing an ellipse, then the field is said to be elliptically polarized. So the linear and circular polarizations are special cases of elliptical polarization. Now we see here the diagrams representing three different types of polarizations. In linear polarization, the electric field traces a straight line, whereas in elliptical polarization, the field traveling in the z direction can have two components in x direction and y direction. Thus, if we represent the equation of Ey component, then it should be E2, which is the component in y direction, sine of omega t minus beta z, where beta z is the electrical length of the line, and it is representing the phase constant. So in general, electric field of a wave traveling in z direction can have these two components. Thus in this situation, if there is a phase difference of delta between the components, the wave is said to be elliptically polarized, and it is not mandatory that the wave has to travel in z direction. It can be considered traveling in x and y directions also. In the circular polarization, we can see an electric field traveling from the antenna traces a circular path. So two extreme cases of elliptical polarizations are circular polarization, where you can see as it is a circle, the radius E1 and radius E2 are both same, and then it can also be a linear polarization as shown in the first diagram, where the value of E1 or 2 is 0. There is another concept, the ratio of major and minor axis in the ellipse, which is called as axial ratio. So in polarization, in elliptical case, the axial ratio is computed, and it is given by AR, axial ratio given by E2 divided by E1. So it's a small topic, polarization of an antenna. It is basically polarization of the electric field radiated by the antenna. You can read this in more detail for understanding the concept of polarization. So in the next video, we will start with array concepts. So we have almost finished all the parameters, basic parameters related to the antenna, and now we concentrate on application of antennas in the form of arrays. Thank you.